This video we are going to learn about theorem on nth roots. Okay, so if z is equals to r cosine theta plus I sine theta is any non-zero complex numbers, and if n is any positive integers, then z has exactly n different nth roots. Okay, so w sub 0, w sub 1, w sub 2, and then we have wn minus 1. These roots now for theta is in radian form, that we will have now w sub k is equals to the nth root of r times cosine theta plus 2 pi k all over by n plus I sine, we have sine times theta plus 2 pi k over n. Or we will have in the degree form, you can have either radian form or degree form. So in the degree form, we will use, instead of 2 pi, we will use 360. Okay, so where k is equals to 2, we have or 0, 1, and n minus 1. Okay, for example, given, we'll have negative 8 minus 8 square root of 3i. So from here, we will have to draw the graph. Okay, so I think this one will be in quadrant number 3, right? Okay, so we will have 8, negative 8, 1, 2, 3, 4, 5, 6, 7, 8, and then negative 8, so our approximately we have graph. Okay, how will we find now the r? So r again is equals to 8 squared plus, we have negative, so negative 8 squared, and then we will have negative 8 square root of 3 squared as well, and then we have to square root this one. So therefore we will have now 64, the other one is 64, and the other one is 64 times 3, so we get 192 because we have 8 times 8, and then after that you have to multiply by 8 times 8, and then after that you multiply by 3. So therefore we will have 64 times 3 plus 64. So we will have now square root of 256, which is equals now to 16. So our r now is equals to 16. How about our theta? So the theta now equal to, so this one is our negative 8. This one is our negative 8 square root of 3. So tangent negative 1 is equal to opposites over, so therefore we will have 8 square root of 3 over 8, right? We get that one. So tangent, okay, tangent square root of 3 is equals to pi over 3, or equals to, we have 60 degrees. So we can write that one in the form of trigonometric form. So therefore we will have now as z is equals to 16. Okay, 16 times, by the way, this one is only our reference angle, right? Reference angle. So from here we have to get the actual measurement of the angle. So this one is 180 over here, 180 degrees plus 60 degrees. So therefore our theta now, our theta is equals to 240 degrees. So we'll have now in the trigonometric form of the complex number, we have 16 times cosine 240 degrees plus I sine 240 degrees as well. But here we are going to solve for the nth root. Okay, so now our n, for example, our n is equals to 4. So therefore, the nth root of the value, so as you see here, square root nth root of r, so therefore we'll have now 4th root of 16. How much is that? 4th root of 16, which is equals to 2. So we can write now in the form of, we have the roots now. In root, we will have 2. So therefore, now this one will become 2 times cosine 240, right? Or theta is 240. No. So we will have 240 plus 360. So let's start with k0 all over by our n is equals to 4 plus I. So therefore we will have sine times I cosine over here. Sine, we have 240 plus 360 times 0 all over by 4. Okay, so therefore we will have 2. So this one is 0. So therefore 240 divided by 4. So therefore we will have cosine 60. Okay, so therefore we will have now cosine, we have 240 divided by 4 is cosine 60 plus I sine 60. Okay, so this one is for our W base 0. What about if our value is equals to W1, our K is 1, so therefore we will have now, okay, so let's clear this one first. Okay, yes, we'll clear that. So what's that one again? We have our W0 is equals to 2 times cosine 60 plus we have I sine 60. Okay, for our W base 1, our theta is equals to 240, right? 240. Our nth root, we have the 16. 4th root of 16 is equals to 2. So therefore we will have now 2 times 200 or cosine 240 plus 360 divided by 4, because we will multiply this one by 1, so it's still the same as that one. And then plus sine I, we have 240 plus 360 as well, all over by 4. So how much is that one now? So we have 240 plus 360 divided by 4. So therefore we will have now as W1 is equals to 2 times cosine 150 plus cosine or I sine, we have 150 degrees. Okay, so that is for K is equals to 1, W is equals, or K is equals to 0. Okay, going back to the original, we have equation, right? We will have, because you observe over here that it will be 60, 150. So therefore, the next one now, if we will multiply that one by 2, it will give you 2 cosine. We have plus 150 plus 90 degrees is equals to, therefore this one now will become 240 degrees plus I sine, we have 240 degrees. How it becomes like that? So because we have cosine, right? Cosine, our original equation, we have y is equal, W is equals to 2 times 2 cosine 240 plus 360 times k divided by 4 plus I sine, we have 240 plus 360k over 4. So we cancel out this one. So therefore, this one now is equals to 90k. So plus 90k. That's the reason why we have 60, 150, we have 240, and then if we will have k is equals to 3, so therefore we will have now 240 plus 330, so therefore we will get 2 times cosine 330 degrees plus I sine 330 degrees. When you are going to simplify it more further, so you will have now 2 times cosine 150, then 2 times sine 150, okay? So you can do 2 cosine 60. So our cosine 60 is equals to square root of 3, and then our sine, we have 60 is equals to square root of 3 over 2. So therefore, we can simplify it more further. So for example, the W0, okay? So we will have 2 cosine 60 is equals to, we have 1/2, right? And then sine 60 plus, we have sine 60i is equals to square root of 3 over 2, okay? Then times 2 as well. So therefore, we will have now, cancel out this one. We will have 1 plus square root of 3i, okay? So if you want to simplify it more further, so you will make this one the same as here. So what is cosine 50, what is sine 50, and then you multiply by 2. The same as on the third, and then on the fourth, we have value of k, which we start from 0, 1, 2, and 3. Okay, so if you have further questions, don't hesitate to comment below in our video. Thank you so much and have a nice day to everyone.